All right, here we are. We're talking about number, here we are, 23 here. Find the equivalent resistance of the circuit shown below. And so we've got an 8, a 9, and a 6 in parallel. And they are in a series with a 12. And so you got to do parallel math for the 18, 9, and 6. And then you got to slap on the 12 at the end. So here we drew it. And so we said we did our parallel math right here. 1 over 18, 1 over 9, 1 over 6. I made it all 18ths. So 1 18th, 2 18ths, and 3 18ths equals 6 18ths. Then you flip it and you get 18/6, which is 3 ohms. So that's not, you're not done though. So then you have to say that whole parallel is in a series with the 12. And so you say the 12 plus the 3 gives you a resistance of 15. So that's number 23. Then every year, the problem I love and hate is right here. Find the resistance of this circuit. And so you're looking at it, and I love that they gave me all those 7s because it's so easy to differentiate between the 7 and the 7 and the 7. Well, a lot of people get confused because they see this guy and this guy in a straight line. And they see this guy and this guy in a straight line. And well, these straight lines are mathematically that P word. Well, that's not how this works though. The P word, parallel, means you have a junction. So right here, where you come together. And that junction splits apart, and then it comes back together. So between this spot and this spot, things are parallel. So here, I drew it out, and I gave it letters. So you can see I got A, B, C, D, and E. And D is that one in the middle. B and C are off to the side, and A and E. So if you start the battery here, and you go from the battery up to A, you have no choices. A is part of a series only. If you went the other way, E is part of a series only. Now up here, though, remember I just talked about junctions? So I'm right and left-handed. Hold on a second. Right here, right there, there's a choice. You could come around through B and C and get back, or you could go through D. Therefore, combo BC is parallel to D. B and C, you have no choices, one path only. Therefore, B and C are a series. So let's look at our math here. B and C are a series, therefore it's 7 plus 7. B and C is 14. D is parallel to BC, so 1 over D plus 1 over BC. So 1 over 14 plus 1 over 7, make that into 2 14ths, so you get 3 14ths, flip it, you get 14 thirds. 14 thirds is easier said as 4 and 2 thirds. Okay, 4 and 2 thirds. So now we want to add this in. 4, hey, focus. 4 and 2 thirds, and you can add 7, 4 and 2 thirds, and 1 1/2 up on your own. And then lastly for this video, we have number 25. So that's this guy here. You've got a 6 and a 9 in a parallel. They are in a series with a 3, and there's a 12 volt battery, and it says find the resistance and the potential difference across each resistor. So we want to find the voltage for every resistor, which means we have to do all that fun stuff here. So starting off, you have to understand A and B is a parallel. That parallel AB is in a series with C. So we need to add that up. Add up the A and B using parallel math. Add C to that. So we came over here. A and B, 1 over 6 plus 1 over 9. I go to 18ths. 3 18ths and 2 18ths is 5 18ths. Flip it, 18/5, otherwise known as 3.6. That is AB. AB is 3.6. So come over here. 3.6. This marker's dying. I guess I had to go with a big marker. Sorry. So we've got 3.6 here for AB. they are in a series with C. So we're going to take our 3.6, we're going to add C3 to it. That makes us a 6.6 for the total resistance. Grab the calculator over here. So that's the first step, is just getting the total resistance. Then we got to fill in all the information for our other parts. We're told 12 volts, so we need to figure out the, I wrote that in the wrong spot. 12 volts. And we got to figure out the current. Well, I equals V over R. And so I'm going to say, let's see, I equals V over R. So 12 volts divided by 6.6 ohms gives me a 1.8 for current. Well, then we had to start distributing things. And we saw that we added 3.6 and 3 in a series way. That means those are a series. So what is equal in all parts of a series? Current is equal in all parts of a series. Therefore, the current of 1.8 is the same through section AB and resistor C. Now that we have two items, we go back and find the third item. So let's start down here on the bottom and say V equals IR. So 3 times 1.8. And I get 5.4 down here. And then V equals I times R up here. So 1.8 times 3.6 equals 6.5. Now I did a little rounding here. That's why these aren't exactly 12. So we've got section AB now. AB is a parallel. Voltage is the same in both parts of a parallel. So 6.5, 6.5. Now we can say I equals V over R and find out these two currents. So it's going to share this 1.8 though. So I equals V over R, so 6.5 divided by 6 is 1.08 here. And then over here, 6.5 divided by 9, and it comes out to roughly 0.72. And that adds up to 1.8. That's how you work through these. Use Ohm's law to get 3 items. Once you have 3 items, use a rule to distribute information to the other ones.